Solving equations is all about understanding inverse operations. Whether it has whole numbers, negative numbers, decimals, or fractions, it does not affect how we solve the actual equation. Fractions, however, have a very different set of evaluation rules that sometimes can be forgotten or confused. So we get overwhelmed looking at equations that have fractions, not because equations are hard, but because fractions are surprisingly challenging. So let's review a little. When you add or subtract fractions, you have to have common denominators. There are some shortcuts that work for this, but the way that works every single time and has the highest chance of the lowest amount of simplification is listing out the multiples. So I'm going to take my first denominator, 6, and it's like skip counting. 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, 6 times 4 is 24. List out 4 or 5 multiples. If you need more, because you don't find anything in the compared lists, then you can list out more multiples. I'm going to list out the multiples of 18. 18 times 1 is 18, 18 times 2 is 36, 18 times 3 is 54. Now I saw right away that 18 was the smallest value in both lists. This is the lowest common multiple. This is also our lowest common denominator. So I need to make equivalent fractions of 1/6 and 5/18, both that have a denominator of 18. If I look at my multiples of 6, 18 is the third multiple. 6, 12, 18. It's the third multiple. So I'm going to multiply my fraction 1/6, top and bottom, by 3. 1 times 3, 6 times 3. That's going to give me 3/18. In my other list of multiples, 18 is the first multiple, so I don't really have to alter the fraction that has 5/18. Technically, I'm multiplying it by 1. That's going to give me my denominator of 18. Now that I have common denominators, I can add my numerators. 3 plus 5 gives me 8. 18 just stays the same. The denominator, when we're adding and subtracting fractions, is very much like its last name. We have 3/18 and 5/18. They join together to make 8/18. Fractions always need to be simplified. In this case, it's a proper fraction, so we don't have to worry about making a mixed number. But we're going to list out the multiples of the smaller values. This is what we call the single mountain method. I draw out my mountain, and I'm going to look at the factors of 8. 1 times 8 is 8. Climb the mountain. 1, 2, 3. I'm going to check all of those factors. 8 divided by 2 gives me 4. It's a whole number. 8 divided by 3 gives me a decimal. 8 divided by 4, well, I'm on the other side of the mountain already. Now I'm going to check. I'm going to divide each of these factors from 18. 18 divided by 8 gives me a decimal. 18 divided by 4 gives me a decimal. 18 divided by 2 gives me a whole number, 9. So that's my greatest common factor. The greatest common factor becomes very important both in simplifying fractions and solving two-step equations that have fractions. So I'm going to divide top and bottom by 2. 8 divided by 2 is 4. 18 divided by 2 is 9. My fraction, my simplified answer here is 4/9. On your own, try the same process. Find common denominators, subtract your numerators once you have equivalent fractions, and then simplify. You can use the shortcut of multiplying 15 times 12 or multiplying both top and bottom by the opposite denominator. However, this method, this shortcut that a lot of students rely on, usually requires you to do a lot more simplifying at the end of the problem. When solving two-step equations with fractions, you'll probably have to multiply fractions at some point. To multiply fractions, you just have to multiply straight across. Multiplying fractions is the easiest skill when it comes to fractions. So let's look at 2/5 times -6/3. I'm going to multiply straight across. 2 times -6 gives me -12. Watch your negative signs. Don't make a mistake here just because of simple negative signs. That's a calculator moment there. If you struggle with negatives, remember, you can plug it straight in. 5 times +3 gives me 15. And now I just need to simplify my fraction. It's a proper fraction, so I don't have to worry about turning it into a mixed number. 12 and 15. I'm going to take the factors of 12, so 1 and 12. Then I'm going to climb the mountain. I'm going to see if 2 is a factor, 3 is a factor, 4 is a factor. And I can check by dividing. 12 divided by 2 gives me 6, a whole number. So 2 and 6 are factors. I put 2 on one side, 6 on the other. 12 divided by 3, which would be the next number to check, gives me 4. The next number I would check is 4 because I'm going in order. 1, 2, 3, 4. 4 is on the other side of the mountain, so I know I'm done. Let's do the double mountain method this time. So I'm going to find factors for both numbers. 1 times 15 makes 15. I always start with 1 and the number. 15 divided by 2 gives me a decimal. 15 divided by 3 gives me 5. 15 divided by 4, decimal. 15 divided by 5, I already have on the list on the other side of the mountain, so I'm done with my factors. Now I just compare the two lists. The biggest number in both lists is the greatest common factor. It's the biggest number that is in both lists of factors. That's what it's common. It's the same in both lists. In this case, 3 is my GCF. I'm going to divide top and bottom by 3. Negative 12 divided by 3 gives me negative 4. 15 divided by 3 gives me 5. On your own, try multiplying 6/5 times 2/8. Dividing fractions is very much related to multiplying fractions. You have to remember to keep it, change it, flip it, and then multiply it. A lot of students forget that last step. Keep it, change it, flip it turns division into multiplication, but you still need to complete the multiplication. So I have negative 4/7 divided by 2/3. I'm going to keep it, change it, flip it. Keep the first fraction, negative 4/7. Change it, change from division to multiplication, and then flip it. Take the reciprocal of the second fraction. So I end up with negative 4/7 times 3/2. I kept the first fraction. Notice I put the negative in the numerator. It's always nice for the negative to have a place. I changed from division to multiplication, and then I flipped 2/3 and made it 3/2. Now I treat it like a multiplication problem. Negative 4 times positive 3 gives me negative 12. 7 times 2 gives me positive 14, and I just need to simplify my fraction now. I'm going to take the factors of 12, list them out. 12 divided by 2 gives me 6. 12 divided by 3 gives me 4. 4 would be the next value or next factor I'd be checking, and it's on the other side of the mountain. I'm going to list out, so I'm going to do double mountain. I'm going to list out the factors for 14 as well. 1 times 14. 14 divided by 2 gives me 7. 14 divided by 3 gives me a decimal. Divided by 4, decimal. Divided by 5, decimal. Divided by 6, decimal. Divided by 7, it's a factor, but it's on the opposite side of the mountain. So I have all of my factors. Remember, listing out your factors becomes a calculator moment. We're just using division to check which values or which factors give us whole numbers. I'm going to search for the biggest value in both of these lists. This is my greatest common factor, 2. So I'm going to divide top by 2, bottom by 2. That's going to give me negative 6/7. On your own, try 12/15 divided by 4/5. You're going to keep it, keep the first fraction the same, change it, change division to multiplication, and then flip it. Take the reciprocal of 4/5, which is 5/4. The process of solving a two-step equation with fractions should not vary as how we solve any other two-step equation. We're still looking at the operations that are present, we're looking at the order of those operations, and then we're finding the inverse operations in the inverse order. So we always ask ourselves the same two questions. What's happening to the variable? I'm going to list the operations in order. I list the operation with the value. The only difference here is that the value is a fraction. So the first thing happening, if I was following the order of operations, if I'm looking at my variable, I'm multiplying by 2/3. Then I'm adding 3/9. Multiplication division comes before addition subtraction. Now I need to ask, how do I undo the operations? I write the inverse operations for each of the current operations. The inverse of addition of 3/9 is subtraction of 3/9. If I'm going to take the inverse of times 2/3, I'm going to divide 2/3. Now I have a list of the current operations in order and the inverse operations in the inverse order. So I'm going to subtract 3/9 and then divide by 2/3. I'm going to apply the first inverse operation to both sides of the equation. This is the only place that seems like it's differing. I'm still using my inverse operations, I'm still using the inverse order, but I have to deal with fractions. So I'm going to apply it to both sides. Now I'm going to evaluate each side of the equation. 3/9 minus 3/9 gives me 0. It's my identity. So I'm left with 2/3 x equals something else. I need to subtract 9/12 minus 3/9. In order to do that, I have to have common denominators. So I'm going to find my lowest common multiple. So I listed out my multiples of 9. 9 times 1 is 9. 9 times 2 is 18. 9 times 3, etc. I'm going to do the same thing with 12. If I look at my lists, the lowest common multiple in each list, the smallest number in each list is 36. In order to get a denominator of 9 turned into a denominator of 36, I multiply by 4 because 36 is the fourth multiple in 9. To turn 12 into 36, I'm going to multiply by 3 top and bottom because 36 is the third multiple in 12. So I'm going to multiply top and bottom by 3 there to get an equivalent fraction. I'm going to multiply top and bottom by 4 there to get an equivalent fraction. This is going to give me 15/36. I'm subtracting 27 over 36 minus 12 over 36. The denominator stays the same. I just do 27 minus 12 to get 15. On the left side of my equation, 2/3 x is still there. We canceled out 3/9 by subtracting 3/9 to get that identity of 0. Now, the next step is I'm going to divide both sides by 2/3. That brings us to step 5. Apply the second inverse operation to both sides. So I'm going to divide 2/3 on the left, 2/3 on the right. So I'm dividing by 2/3. I'm going to evaluate each side of the equation. 2/3 divided by 2/3 automatically turns into 1. So I don't have to worry about changing the left side. I know I'm going to get my identity and I'm going to be left with just x by itself. But I have to keep it, change it, flip it in order to get 15/36 divided by 2/3. So I'm going to keep it. I'm going to keep 15 over 36. I'm going to change from division to multiplication, and I'm going to flip from 2/3 to 3/2. So I'm going to take the reciprocal. Multiply those, I get 15 times 3 is 45. 36 times 2 is 72. If I simplify that, I see that they're both factors of 9 or multiples of 9. 5 times 9 is 45. 8 times 9 is 72. There's my final answer. If the question or equation starts with fractions, it ends with fractions as a solution. Let's try one together. In this case, we have 3 fractions, so we need to be very careful. 1 is a mixed number. Mixed numbers are great for communicating values. Improper fractions are great for calculating values. So negative 1/4 or 1 1/4 is no use to us as a mixed number. I could rewrite that as minus 5/4 x. 4 times 1, the whole number, is 4, plus 1, the numerator, is 5. That's how I get 5 over 4. So if I answer the same two questions, what's happening to my variable, how do I undo it? I'm multiplying by negative 5/4, and then I'm adding 3/5 or 3/15. Be careful. The minus we attributed to the negative 5/4. I'm not subtracting 3/15. I could rewrite this equation to be 3/12 equals negative 1 1/4 x plus 3/15. Be careful with that operation. It's not subtraction. I'm going to ask myself, how do I undo those operations? So I write out my inverse operations in the inverse order, and now I have a map. I know exactly what to do first, what to do second. I'm going to subtract negative 3/5 or 15ths, or subtract positive 3/15 from both sides. That's going to cancel on the right side because I get my identity. Anything minus itself is just 0. On the left side, I need to find a common denominator before I can take 3/12 minus 3/15. Notice order matters when we're subtracting and dividing, so be careful. So I'm going to look at those two. I'm going to find denominator between 15 and 12 that works. So I list out my multiples of 15, list out my multiples of 12. They both have 60. I'm going to multiply 15, or top and bottom of my fraction that has 15 as a denominator, by 4, because if I look at my list of multiples, 60 is the fourth multiple of 15. So I multiply top and bottom of 3/15 by 4, top and bottom of the fraction that has a denominator of 12 by 5, because 60 is the fifth multiple in my list of 12. Now I have my two fractions. You can write this as 15/60 minus 12/60. I like to rewrite subtraction as addition of a negative value. Now I know that 15 plus negative 12 gives me positive 3. I can simplify that down, or I can just move forward. I'm going to have to simplify at some point, so you can make life easier by simplifying now or just simplifying at the end. Next thing I said I'm going to do is divide by negative 5/4. So I apply that inverse operation to both sides, and then I evaluate. Anything divided by itself is just 1. So negative 5/4 divided by negative 5/4 is going to cancel out and just give me x on the right side. However, I need to set up 3/60 divided by negative 5/4. I can't do straight division with fractions, but I keep it, so I keep 3/60. I change it. I'm going to change division to multiplication, and then I'm going to flip the fraction. So I'm going to multiply by not negative 5/4, but 4 and negative fifths. Notice it's the reciprocal. I flipped it. 3 times 4 gives me 12. 60 times negative 5 gives me negative 300. Now I can simplify. I have 12 and I have negative 300. I could list out my multiples, or I could just simply divide top and bottom by 12. 12 divided by 12 gives me 1. 300 or negative 300 divided by 12 gives me negative 25. I could have also guessed and checked. Not a reliable method, but it will work if you struggle with finding a greatest common factor. 12 and 300 both have a factor of 6. So if I divide 12 by 6, I get 2. 300 divided by 6, I get 50. Well, those are both even. 2 divided by 2 gives me 1. 2 divided by, or negative 50 divided by 2 gives me negative 25. So guess and check gets very complicated. It's easy to lose those numbers, hard to juggle them all in the air. Let's try a shortcut. If you really struggle with fractions, this might be a good alternative. It gets rid of all of the fractions and turns it into something we know. One big shortcut or tip that makes life easier is try simplifying the fractions before you start. I see 4/24. Well, I know that can simplify down. That's both has a factor of 4. 4 divided by 4 is 1. 24 divided by 4 is 6. 5 and 25 both share a factor of 5. That'll simplify down to 1/5. 9 and 27 share a factor of 9, so I end up with 1/3. I could go forward from here and solve it using the basic methods we've already talked about. I would just need to remember to add 1/3 to both sides and then multiply by 5, which is the inverse of dividing by 1/5. However, if I want a shortcut to get rid of all of those fractions, I can find the lowest common multiple of all three. To do this, I'm going to list out the multiples of 6, 5, and 3, all of our denominators here. So 6 times 1, 6 times 2, 5 times 1, 5 times 2. I do skip counting. I may have to go back. In this case, I had to list out a lot of multiples for 3. I had to list out a few more multiples for 5. If I don't see the multiple as I'm listing them out, I need to keep listing. In all three cases, 30 is the smallest number. So I'm going to take that value, 30, and multiply the whole thing by it, the whole equation. Now you could get into fractions. Anytime you have a whole number, it's really 30 over 1. So I could be doing 30 over 1 times 1 over 6 and multiply 30 times 1 and blah, 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 blah. Or treat the fraction as what it is. It's a combination of a little multiplication and a little bit of division. So I could simply do 30 times 1 is 30, divided by 6 gives me 5. 30 times 1 is 30, divided by 5 gives me 6. That's how I got 6x. 30 times 1 is 30. Divided by 3 gives me 10, or in this case, negative 10. So I turned that nasty, scary fraction-filled equation into a simplified version, and then I got rid of the equation or the fractions altogether and turned it into a two-step equation that looks a lot like what we started this unit with. The only trick is that your final answer has to remain an equation. So I'm going to solve this. First thing that's happening to my variable, I'm multiplying by 6, and then I'm subtracting 10. So to undo that, I'm going to add 10 and divide by 6. If I add 10, that's going to cancel out the negative 10 and make the left side of the equation 15. Now I'm going to divide by 6 on both sides, and that should give me my variable x by itself on the right. Now, since it's a fraction, it starts with fractions, it has to end with fractions. I can't just do 15 divided by 6 and get a decimal answer. I need to simplify this down. 6 goes into 15 one time, or 2 times, with 3 left over. 3/6 simplifies down to 1/2. That's how I get 2 and 1/2 as my final answer. I could substitute this back in and check my answer if I wanted to.